welcome to you first control system lab. Today in this video I will just go through about the first control lab that we will do. Now this is the first lab, and this is actually an introductory lab towards Matlab and its toolboxes that are normally used as a software package for control system design. So basically today we will discuss generally about some commands about using Matlab, then look at some toolboxes, and then go to on Simulink and do some manipulation using this Matlab. Okay, the purpose of this lab is to introduce the student to some of the more useful aspects of Matlab and to illustrate how the software may be used to solve problems in control system design. So there are other software as well, but for this course normally I prefer Matlab here. Okay. Now if we look at this is available to you. This is the Matlab generalized interface, which has folder directory is available on top left here. Then you have this workspace here available, which has some variables. This is known as command window, and this is the script file. Okay, so this is the general layout of a Matlab toolbox when you open it. And now today what we do actually, we will look at how we do time domain analysis. This part introduces the reader to time domain analysis using Matlab. It uses command from control system toolbox. So here the basic idea is using this control system toolbox to solve the control problems. A list of commands can be found just typing help command. So let's do it here. So this is command window, and I just type help control, and let's see what happened here. So I'm waiting for some time to display the result. Now this help will fetch all the possible commands of the toolbox that is maintained by the Matlab for control. Okay. Now if I look here, so if you need any command related to control, you just use this control, and control system toolbox version is available. Now you have generalized that. For example, set control system toolbox preferences. You have overview of input output models, dynamic systems, and linear time invariant systems. Okay. Now graphical interface is also available. First one is LTI view, where you can look at the time and frequency response analysis. And then you have another tool that is designed for single input single output. So this is also known as CISO design tool, that is interactive compensator tuning, and here you can easily design control for single input and single output system. Another one is the PID tool. It is also interactive PID tool that is used for PID tuning. And the last one is another tool that can use to configure the single input single output tool. Okay. Now linear models, we have if you know, because from your signal system knowledge, that you normally represent linear time invariant system using transfer function. Now for creating transfer function, we have command here TF. Similarly, we have another command that is for zero pole and gain, which is also very important when we write the transfer function of a dynamic system. So we can normally know the pole and zero. Then using this command we can write the transfer function using the pole and zeros. Similarly, we can generate state space models. We also write or create descriptive state space model. Also we introduce delay terms in the state space model. Also, if we want to look at the frequency response of the system, So we have FRD model available for this. Also we have PID controller. This is a very famous controller, so it is also available here. So this is the standard form of PID control. Similarly, we have create pure continuous time delay using TF-EXP. Also we have a digital filter command available. So these are some commands that you can use to design and analyze your system. For data extractions from these systems, we have other commands. So the main idea here is that you can easily use these commands to do the control system analysis and design. So there are system interactions. So as we go progress in the course, we also do some these commands. These commands are required to analyze the system and design the controller. So here we have time domain analysis, where we can use step info, impulse, initial. If we need some general purpose response or output to a system, we use LSIM. Similarly, we have LSIM info that gives the linear response characteristics. Then we can generate input for LSIM, and also we do covariance response to white noise. Okay. So in for frequency domain analysis, we have all these commands available with us, which we can use. And then sometimes we need to simplify the model or minimize the order of the model for what you say, to remove the redundant zeros and poles or cancellation poles. We use these models to do that. Then the last bit is the compensator design. So we can design compensator or controller using PID tune, using root locus, using pole placement technique. We can design estimator for gain, or we can do the regulation. We also design the state space controller, that is LQG, linear quadratic state feedback regulator, and so on. So also we have command state estimator. Estimator normally we use when we required some unknown information from the output of the system, unknown dynamics, okay, that are not available to extract from the output. Then we have time delays. Then also if we go to state space or modern control, these are some commands for that. Also for frequency response using data models, we have this thing. For generalized linear model, these are the few commands. So the main idea is that there are a lot of commands available, and there are some operations that can be overloaded, and this is a term normally we use when we can use operation for other purpose as well, okay, or sculpturize the operations. So overloading is the term not used. So there are commands. The basic idea here is that whenever you require a command to do manipulation, you just type help control and you get all the commands that are required to do your lab work. Okay, so for example, if I wrote help step, what happened here? Let's do it here, and I just type help step. So look here, when I do that, it will give me this information about this command, that is step. So this command is used to give step input to the system. Okay, so this is actually help will provide you all the information you require to do some process. Okay, now let's see, we have example here and we want to do this example, and just look here, the step help is written here. Okay, so what is step? Step is a step response of dynamic system. So you have to give dynamic system as a variable to this function, and it will give you output with time. Okay, so it gives you the step response. Okay, let's do an example that is given to us here. So example is that consider a first order transfer function. So why we call it first order? Because there's only one pole and the denominator, so number of poles tell the order of the system. Here this is known as first order system because it has only one single pole. The impulse function response function can be created by using the following command in script. So if you want to do the impulse response, how we do that? So let's copy this code from here that I wrote for you guys. So that I copy this and I can just paste in the script file. Okay, so I have to change this variable here. It's not known to the system. I just put the comma here. Now it's now fine. So there are different ways of running these scripts, but I'm not going to solve this. Save this, so that's why I just use right click and evaluate the section. When I do that, it will paste all the codes in the command window and start running one by one. So what this command says, it clear all the workspace, then there's a num defines the numerator. There's no pole here because the equation is 1 over s plus 1 and denominator s, for s variable I put 1, for 1 I put 1. If 2 was written, then I have to put 2 here. So then I use impulse, which gives the numerator of transfer function, denominator of transfer function, and grade on, then print the system. Okay, so let's Matlab is a bit slow here, so due to what you should, now this is the impulse response. So look here, this is the time axis and this is the vertical axis, which tells you the amplitude here, and it is written this is an impulse response. Okay, so look here, impulse response start from 1 and die down to 0 around 5.1 second. Okay, die down to 0. So this is the impulse response. So if you remember, impulse response is actually gives you initial condition response. So we will discuss these things in detail in lecture, but so this is the response, and look at this is the figure you are getting. Now if I go to the command window, I print the system. Look here, this is the transfer function that was asked in the lab to do it. Okay, now this is the figure, and you can use there are options here. Okay, you can save figure as Matlab figure, or you can save as a JPG that you can use. There's another option, you can copy the figure. Okay, and you just paste in Word or where you want to do the report. No, my main thing here is you have axis here. This is y axis and this is axis, and this is the response. Okay.